Okay, hello students. This is Ship Dynamics, and for your own good, okay, you don't need to tell me thanks, but this class is also taught in English, completely in English. Okay, so that's it. I'm not asking for your permission. This is something that it is for your own good, so we're going to do it this way. Since it's not such a large class, I saw that there are 21 people registered. So in a class with 31 students, there is plenty of space for participation. Okay, so everybody will have the opportunity to say something, to practice English communication. So it's going to be useful for everybody. Okay, so today I would like you to know in detail what we are going to be doing during this semester. Okay, there are very special regulations. There are special details about this semester, since we are in hybrid, okay, in the sense that some activities will be held online, and after 4 weeks we will be meeting in person on campus. Okay, so more or less that's the general idea. And at the end, I hope we will have some time in order to say something about chapter 1. This is just a review of topics about chip oscillations, or I'm sorry, about oscillation of systems with several degrees of freedom. So I'm sure you remember that from the previous class. So this is just a review, quick review. Okay, more or less that's the agenda for today. I'm going to share the screen. Andy, can you confirm me that you see my, can you see my full screen or half?
Only half, doctor.
Who is speaking?
Doctor.
How about now? Full screen?
Yes, doctor.
Okay, good. So this is just a general slide. Let's go on with the next one. Okay, so this is a special since this is just a two hour per week, okay, of theory, but it has 1 hour of practice. I'm going to teach both. So I'm going to teach 3 hours per week. So you have to see me probably most of the semester for 3 hours per week. At the end of the semester, we're going to have participation from Engineer Isaac. You know him. He's going to explain to you how can you use MaxSurf in order to prepare the calculations for the project at the end of the semester. And also, when we develop lab practices, he's the one who is going to direct you. Okay, so that's his contribution. And the rest of the semester is mine. Okay, this is a prerequisite. We will be talking about oscillation of multi-degrees of freedom system. This is something that you studied in mechanical vibrations. So plenty of vibrations during this semester. This is something that is causing some problems, okay? At the beginning of the semester, we told you that we will be going slowly toward the normal situation at the university. That's in-person classes and everything. But this semester is just a transition. So we're going to have classes online, and we're going to use the Zoom platform, okay? And we're going to have two sessions from 4 to 5:30. And the second session, okay, this is supposed to be presented by Engineer Isaac. But since I'm going to do it, then I'm going to work from 16. Oh, man. I'm going to work from, let's see if this works. I'm sorry, from 16. From 16 until 17:30 on Thursdays. So that's the final schedule that we're going to be following. Does anybody have any problem with this new schedule, people? Does anybody has any problem with this schedule? Tuesdays and Thursday from 4 p.m. until 5:30 p.m. So you can see that immediately that is a great advantage, because in this way we can teach, we can work both days at the same time schedule. So I see this as an advantage. Is there any problem from anybody? No, good. So this is approved. Then all of this is going to be recorded, and you're going to be able to see in Teams. So if you want to look at them, yeah, you will be able to see this in Teams. All the homework, it's going to be in the Aula Virtual. So I'm going to post the assignments in Aula Virtual, and you have to load them, your work, in the same platform, okay? And finally, we're going to have closed book evaluations and project presentations in person, okay? So every 4 weeks, we will meet on campus, and then we will have, I will explain in a minute, we're going to be doing some lab, we're going to do some evaluations, and at the end of the semester, we're going to do project presentations. This is going to be in person. If you have any question, please interrupt me, and I'll try to answer as soon as I can. Then this is a course description. We need to erase this. Miss Pinkai, are you here?
Yes, I am.
Why don't you people turn on your camera so I can recognize you, because it's difficult for me. I usually do not recognize. Okay, go on, Miss Pinkai. Could you please read it sentence after sentence, please?
Yes. Course description. In this advanced level course, the linear response of a ship to irregular waves is studied.
Okay, so that's a general, that's like the general objective of this class, okay? And then you can see immediately there is a nice word, irregular waves. So if you study ship dynamics and calculate the response to regular ships, irregular waves, that is not very useful, because to do any conclusion, you have to consider a certain amplitude of the waves, and immediately you face a problem, because in the real world the waves are irregular, and it's difficult to define or select an amplitude. See, so immediately we have to go one step further, and that step further is calculate the response of the ship to irregular waves. Okay, go on, Pinkai.
It starts by reviewing free and forced oscillation of systems with 1 and several degrees of freedom.
Okay, so in this class, we're going to do two analyses. In chapter 3, we're going to analyze the ship in what we call the vertical plane. So that's the combination of heave and pitch. Don't worry, in the adequate time, I will mention what are the names of all of these motions of the ship, okay? And in chapter 4, we will analyze the response of the ship in the roll motion. And that's, we consider that as an uncoupled motion of the ship. Okay, so for that, we need to remember, this is just a review of what we learned in mechanical vibrations. Okay, so natural frequencies, in the case of several degrees of freedom, there are 2 mode shapes and things like that. And when we talk about force by oscillation, of course, we need to include excitation. And one of the very interesting things is that next, Mr. Manrique, would you please go on? Mr. Manrique, are you here?
Yes. So then, aided mass to simple bodies in calculate using potential flow theory.
Okay, so the thing is this, you need to receive an explanation about this. The thing is this, up to, I think it was 3 years ago, our study program lasted 4.5 years, right? Then the CES, the Council for Education in Ecuador, decided that it was mostly recommended that we should study only 4 years. So we had to force in 4 years. So what we did was we took some chapters from the previous class of hydrodynamics, and we moved it into ship resistance and propulsion. And some other topics, we move it to ship dynamics. So that's why we need a specific chapter on an application of ship hydrodynamics in here. And that's chapter 2, basically. Okay. And the concept that we're going to be needing is the application of Bernoulli's equation. Okay. And you said, okay, wait a minute. We studied Bernoulli's when I was in high school. I know. But the big difference is that in high school, all the problems that you solved were steady, right? So you said, okay, I have a body moving with constant velocity. The problem is that in ship dynamics, you go up and then you start coming down. So the velocity is positive and then it's negative. So the motion is not steady anymore. And you will see that when we deduce Bernoulli's equation for this class, we're going to have a term which is the derivative of phi, that's the velocity potential with respect to time. Okay, so that brings a lot of interesting things for this class. And after that, we calculate pressure and we integrate pressure to get force. And then when we analyze force, even though if we consider an ideal fluid, no viscosity, and you will see that the net force is not 0. Remember, when you analyze a body moving in an ideal fluid, well below the free surface, net force is 0. In this case, it's not. Why not? Because we are considering acceleration. So when we do this, see, well below the free surface, ideal fluid, you move it like this. And even though there's no waves, even though there are no viscosity, there's going to be a net force on the body. And that net force will be the product of minus the acceleration times a term. And that term must have units of mass, right? That's why we call it added mass. So we're going to do that in chapter 2. Go on, Manrique.
Yeah. Also, couple heave and pitch oscillation and uncoupled roll are studied under the action of regular wave.
So in chapter 3, we consider combination of heave, that's the vertical oscillation, and pitch, that's rotation with respect to a transverse axis. So when the ship pitches, the bow goes up and down. But we have to analyze it coupled. And then we studied roll. The problem with the roll is that it's a very difficult problem to study in realistic way. So when you have the ship and you roll for 3 or 4 degrees, I mean, the GZ curve is not line anymore. Start bending a little bit. So quite easily, you start getting into nonlinear behavior. Another very, very complex problem in the roll problem is that the damping is extremely important. And the damping, in this case, in the roll, cannot be analyzed using potential flow. That's ideal flow, ideal fluid theory. You have to consider viscosity. And so far, yes, Professor Ruben is doing a lot of effort trying to analyze real flow problems, including viscosity. But still, we are away from solving that completely. So for these cases, we need experimental results, okay? And some years ago, 4 or 5 years ago, one of our graduates, we did a lot of work with a model of a fishing vessel. And we can use that information in order to make an estimation of that parameter. It's a very delicate one. But you see that in this case, we restrict our calculations to regular waves. So chapter 3 and 4, we're going to consider that the wave is like that. So it's a constant times e to the I omega t minus kx. Real part of that, of course. But then we go further. And then Ms. Guthenberg, please go on.
Yes, doctor. Following the response of a system to a random excitation is analyzed. And finally, it is applied to the case of the ship subject to irregular waves.
Okay, so first, we do something very general. So let's take a system, 1 degree of freedom system, okay? And let's suppose that we have an f of t, which is not harmonic wave, it's harmonic signal. Okay, and in that case, what we will obtain is that the RMS. Do you remember from statistics, RMS? What does RMS means? Guthenberg, do you remember what does RMS means? RMS?
No, I don't understand.
No, anybody? RMS? No? It's root mean squared. So when you have an irregular motion, usually you have an average of 0. So if you take this signal up and down, up and down, up and down, you calculate the average is 0. But the problem is that with this signal, with that average 0, the ship is moving. So that's not much of useful. So what we can do is we can calculate the average, but of the square. So in that case, you will get a positive value, because even if you have positive or negative values, when you square it, you turn it into a positive. And when you add, you have something which is different than 0. That's the mean square. And what you do is you have the calculate the square root of that, and that's the RMS, root mean square. Don't worry, we're going to be reviewing all of this. And then finally, we can calculate the response of a ship to irregular waves. And the way we do it here is we calculate what we call the spectrum of the response. Spectrum of the response. So we're going to be working with spectrum of the incoming waves. See, from time to time, you listen that, for example, in the ship was moving in sea state 3. What does that mean? Okay, that we can estimate that using a spectrum. But with that, we calculate the spectrum of the response of the ship. And with the spectrum, we can do certain implications. And we can do some evaluation of the response of the ship. That's for the semester. If you have any questions, stop me. Okay. Textbook is the book from Professor Lewis. This is the classical P&A with 3 volumes, okay? And the one that I'm mentioning here is volume 3, okay? And this volume has, I think there are 2 chapters. The first one is the response of the ship in waves. That's the one that I'm using here. And that was written by Professor Beck and other authors. Professor Beck was professor at the University of Michigan. Then we have some references. Thompson, remember that's the one that we use in mechanical vibrations. Dean and Dalrymple. It's very nice, very, very nice book about water waves. Very nice book. Lewandowski, he's a researcher. I think he's associated with, I think it's right now in Washington or something like that. Newman, Marine Hydrodynamics. This is a very classical book in hydrodynamics. It's a classical one. He was a professor at MIT. And short ago, I think that book, I think it was 50-year old, I think. No, 50 now. But it was a very famous, a certain anniversary, very important anniversary that this book accomplished. It's a nice book. And finally, this Lloyd, it's a nice book. It has a very nice explanations on very practical things. I think it was last year, we analyzed with another engineer. We did some time simulations of the response of a ship using an active control of systems, okay? And we used a lot of information from that book. And so I said, this is a nice book. I just brought it as a reference. People, be careful. Be careful. For example, Lloyd, that's from England. Lewis and Beck, they are from the US. Thompson, he's a mechanical engineer. Dean and Dalrymple, those are oceanographers. So every area of engineering uses a different terminology. So be careful. Okay, so what I suggest, this is something that I've said many times at the beginning of the semester. What I suggest is try to come to class, try to take notes, and stick with your notes. Read it, reread it, read it again, and at the end, you will understand. If you start jumping from one reference to the other, you will get confused because each one of them comes from a different background. See, if you compare, for example, the terminology of Lloyd's book, it's from England. For example, if you use Thompson, okay, this is a wonderful book in vibrations. But the problem is that, remember the equation, you said M acceleration plus K displacement equals 0, right? In ship dynamics, we don't call it like that. We call it A acceleration plus c displacement. I mean, so if you try to combine different references, you will get confused. My suggestion again is class notes, class notes, class notes. Okay. Newman. I think Newman was a mathematician. Can you imagine? So my suggestion is try to stay with the class notes, read it, reread it, and at the end you will understand it. Okay, I'm preparing class notes. I don't think I'll be able to complete the full translation. So I have 2 or 3 chapters in English and 2 or 3 chapters in Spanish, but I don't have more time. So probably by tomorrow, I will just print it, whatever I have, and that's it. So if you want to have the class notes in printed version, okay, please send an email to our assistant, okay? The assistant, I will set the name at the end. It's Miss Kinde, right? So at the end of this week, I will take this and I'll send it to the printer and he will make copies. If you did not ask for a copy, don't come to me. I don't have the time to go again and make a copy for you. So if you need a copy, ask and we will prepare it for you. It's about $5, including the binding and all of that, more or less, okay? For those of you who live outside the city, if you're interested, let me know, okay? And we can see if we can try to send it to you using one of these transportation systems, if possible. If not, you're welcome to visit Guayaquil and stay a couple of days at the university and then go back to your city. Yeah, that's all what I can do, okay? So if you are interested in that, you have to send an email to Ms. Kinde. She's the assistant for this class. These are the objectives. Okay, we want to analyze the response of the ship. We're going to be assuming that it is rigid, so it doesn't deform. It's a very strong assumption, but it's not so bad. And then we solve them when they're facing regular waves using the coupled differential equations of motion. We use this in mechanical vibrations. Then we use a rotational flow. That means there is no viscosity. And we're going to present the concept of added mass. And then we're going to say a couple of words about gravitational waves, okay? Because gravitational waves will represent the excitation, the whole surface. So we need that. And then we also are going to analyze the uncoupled roll motion. See, I separate objective 1 from objective 3, because in the case of roll, we're going to analyze it uncoupled. So it's a single motion. But then we have to talk, as I said before, we're going to spend some time explaining how can we estimate the damping coefficient. So that's the key of this problem. And finally, the first 3 objectives are related to regular waves, harmonic motion. But the problem is that the real world is not harmonic. So we have to use some simple statistics, some theory from random processes in order to be able to take characteristics of the waves and apply to the ship. And we're going to do here, you can read using the response spectrum. That's what we are going to calculate, the response spectrum. And with the response of this, the spectrum of the response, we will be able to calculate some parameters to estimate the response of the ship. That's what we want to gain. These are the topics, okay? More or less, I would expect here to have the first quiz. Then here, we're gonna have quiz 2. Here, we're gonna have quiz 3, okay? More or less, on quiz 2, that's the exams week. Okay, so here, that's exams week. And then you have to come and all of that. And at the end of here, you're gonna have to complete the project. Okay, so as you can read here, you got 4 and 4, that's 8. So that's about 4 weeks. So the last 3 weeks is basically learning how to use MaxSurf and then doing the calculations, okay? At the beginning, about here, I will ask you to select the ship that you're going to be analyzing for the final project. So we'll go in steps, okay? So when we get to chapter 6, you will have the ship with all the characteristics, lines, distribution, things like that. So for the project, you'll simply apply MaxSurf to calculate and analyze. Okay, as it says here, MaxSurf, that's the one that we're going to be using. We have license in the university to use this program. And at the beginning of chapters, here at the end of chapter 3, we're going to have the first explanation. How can we use MaxSurf? And then here, we're going to have a review, how to select certain random characteristics. And at the end, you can use it and analyze the results. Okay, so we go in steps. For all of this is very recommended that you know how to use Excel. And the problem with this is that you spend a lot of time figuring out how to prepare a plot. And the problem is that you waste time figuring out how to prepare a plot. And what we need from you is, okay, have the plot and analyze the results. I want you to really spend time analyzing results, not in preparing the plots, okay? So it's a good idea if you have, you can take any online courses about Excel, okay? So during the semester, you don't spend too much time figuring out how to prepare a plot, okay? That's just a suggestion. This is how are we going to be, you are going to be evaluated. Okay, in the first evaluation, the first grade, we're gonna have 2 quizzes. The first one, you see here, 30 points is short because this is a combination of vibrations and it's just a review. That's why this is worth only 30 points. The second one, this is during the exams week, and this is about mostly about heave and pitch couplet. So that's why this is worth more than this one. And then we have assignments, lab. I will say a couple of words about lab in a minute. Remember, all of this is obligatory. For the second part of the semester, there's going to be only one quiz. How many quizzes are we going to have, Ms. Astudillo? How many quizzes are we going to have in the second part, Ms. Astudillo?
Good afternoon, Doctor. Only 1 second in the
Only
second.
one, only one. So please be careful because this is worth 30 points. Okay, so we're going to have a combination of role and some concepts about random response. Okay, so please pay attention to that because there is only one quiz in the second part. We're going to have assignment lab reports. Here we're going to have 2 lab reports. And finally, we're going to have the final project. And this is clearly here. One thing is the oral presentation and another thing is the report. Okay, the oral presentation, you'll see that there is some, I evaluate the member independently, each member of the group. For example, when you make a presentation, I evaluate the communication, the speaking. So it's not the same for everybody in the group. Similarly, at the end of the presentation, I ask questions. And that questions allow me to evaluate each member of the team independently. Okay, so it's not one grade for everybody. And in the second part for the report, okay, please, this is connected to MaxSurf. Okay, so I'm going to insist in the coming weeks, but you have to be aware that if there are 3 people, the 3 need to know how to calculate the response of a ship using MaxSurf. So somehow I'm going to make sure that you all know how to do it. This is the first day of classes. You are warned. This is something that you know. Every work in this class is obligatory. Okay, this is not new for you. And of course, the third evaluation, see, it's like it doesn't exist. It's there because the regulations of the university forces me to do it, but think that it doesn't exist. And what's the reason why I do that? Because we want, when you graduate from this university, when somebody asks you for a calculation, a project, okay, when you turn in your project, okay, think that your project has to be very well reviewed. Don't think that you turn it in, they will tell you, please correct this, please correct that. No, there's no second opportunities. If you are not responsible for a stability analysis, that ship may capsize. People will die. What are you going to say after that? Okay? So that's why there are no second opportunities in this class. You don't have the time, come back next year. That's the summary. Okay, that's the reason I do this. I give you the examen de mejoramiento. Yes, I will give it to you. But believe me, this is an extremely difficult exam. I will say it one more time. It's extremely difficult exam. Okay? Any questions about this? Ms. Sayo, what do you say? What do you feel about this comment about the mejoramiento?
I believe
you
that it's
agree?
okay.
Do you disagree with me about this?
No,
You can disagree, of course.
I agree because in the professional life, we don't have second opportunities. It's so
Exactly.
difficult.
Yeah. And not only that, unfortunately, our university has many enemies. They are waiting for you to fail. They are waiting for you to fail. So we cannot allow ourselves to fail. Okay, so when somebody asks you for a calculation, put your best, the best first time, not the second, the first. You have to stay awake the full night, yeah, do it. You have to say to your friends, no, I cannot go to that party because I have to complete this assignment, do it. If you feel that, yeah, you are a little bit sick, you have to wake up, stand up from bed and sit and think and calculate. That's the way we want you to graduate. Okay? There are no second chances. Okay. This is something that it's not new for you since you have taken many classes from me before, right? So I hope this is not new for you.
Doctor, I have a question.
Yep.
In the project, we can use the same sheet that sheet design.
Yep. Yep.
It's a, thank you, Doctor.
For those of you who are taking ship design, yes, it's not recommended. It's necessary that you take your project and analyze it here as far as ship dynamics, the response in waves. Yeah. We agree with Johnny, the instructor in ship design, that we're going to be doing this way. Yeah. So you don't need to worry about that. But the problem is that what happens when you have a group of 3, then believe me, you have to concentrate. I mean, everybody has to put some effort in there because there are 30 points here from your project, and I want you to really earn it. I don't want to give anything for free. So, of course, if there is somebody in taking ship design, is he or she is very interested in completing the report. So it's possible that some of the persons in the team will get lazy and wouldn't contribute much. But I'll try to identify that because I need everybody to contribute in the teamwork. Thanks for asking. Okay, what else? This is a continuation of previous thing. There will be 3 in-person evaluations. There's something that we said, 1 after chapter 2. So here, of course, you have chapter 1 and 2. So that's a lot of vibrations and a lot of hydrodynamics. Then after chapter 3, okay, but of course, chapter 3 is a combination of heave and pitch. And you can see that it's a lot of concepts from chapter 1 and 2 in the 3. So please, I know that it's not cumulative, but when you take the quiz the second quiz, there's going to be a lot of information from this previous one. So yeah, that means that this course is well prepared. That's all. Okay, so you have to be aware of that. That's that. We will have 3 experiments. This is going to be in-person experiments in our CMAR lab. The first one will be several degrees of freedom. I want you to analyze, we have it's like a model of a building, something like this. And we have a weight here, another here, and another here. And we can make this to move, okay? And then we can identify here the natural frequencies, F1, 2, and F3. It's gonna be nice because we have some strain gauges. And according to the mode shapes, the phase shift between these signals are going to be very interesting to analyze. So it's nice, okay? Then we're going to do roll damping, okay? I don't know how to do it, but let's see if we can find a pool, okay? So we can calculate this. And the idea would be that if we were able to apply Imeno's process in order to estimate the roll damping and then compare with the values that we obtain from the test. That's during the exams week. And this is after we have completed chapter 5, okay? For example, we can take this and this motion, the base motion, instead of doing some harmonic motion, as in the first lab, in lab 1, we can do the same test, but in this case, we can apply a random motion to the base. Okay, so you can do this like this. Okay, we can measure the response and try, let me say one more time, try to compare our experimental results with our calculations. Okay, that's our plan. Okay, now groups of 3 people. Okay, if you are 21, Andy, how many students do we have here? Andy?
Well, we have 20.
No, but in total?
In total, 19.
Okay, total 19. So we could have 6 or 7.
21, doctor, sorry.
21, so it's about 7 groups. Okay, so we can, it's a nice amount, right? Because we could have a nice competition. But anyway, I need in each group to have at least 1 person from outside Guayaquil. And I need to have at least 1 woman. In a minute, we're going to allow you to introduce yourself so we can know who are from outside, okay? But that's a good way to integrate. You will form the groups. I'm not going to choose your teammates. You are responsible for that. So if the team has problems, don't come crying to me. Don't come crying to me. Who is going to choose your teammates? Mr. Jimenez, who is going to choose your teammates? Mr. Jimenez, who is going to choose? You or me?
Me. I choose
Yeah.
my team.
Who is responsible then?
Me, doctor.
Exactly. So, okay, don't choose somebody because you play soccer with him. Choose somebody because you know he's responsible or he can complement what you do. Okay? I don't know if this is something else. And let me erase this. Let me erase this. There are some online. This is something that we all know, but just in case, okay, we cannot allow you to come directly into the session because we have had some bad experiences, people coming into the session and publishing something odd in our session and things like that. So you have to come into the waiting room and the assistant will allow you to come in. So it's plan that you have to be a couple of minutes before the date that we are going to start. Okay. As we said before, every session will be recorded. We're going to put it into the Teams platform. Student assistance is not controlled. If you don't want to come to class, fine. That you're mature enough. You take your own decisions. But yeah, we keep control of those who don't come. Okay, so if we are seeing that somebody doesn't come to class, see, my responsibility is to send him or her an email asking, is everything okay? I mean, can we do something to help you? But that's all. That's all what we can do. But that's, I mean, you're free. You don't want to come, that's fine. Please try to get your microphones off, but remember, try to remember that if I ask you to participate, you have to turn your microphones on, of course. You ask something, write something or ask something through the chat. And since we have always an assistant, he will call my attention and I'll try to answer your question. Or if you raise your hand again, the assistant will ask me to answer your question. If I ask you to participate, if you have your camera on, yeah, I can see who you are, but otherwise, please say your name, because unfortunately, if I walk on the street and I salute you, the explanation is simple. I just don't recognize you. I mean, it's so difficult. This morning I was at the university and somebody come into class and say, hello, doctor, and all of that. And I said, I shake hands and all of that, but probably he saw in my face, my eyes, that I didn't know who this person was. That's the problem. So that's why I need you to say your name so we can at least start having a rough idea who people are, okay? This is something that you know, so I'm not going to say much. Oh, please, I want you to take this page, okay, and sign it somehow. You don't need to print it, okay? So if you can take this somehow, or for example, what you can do is you can sign, okay, in a paper, take a picture and insert your signature in there. And then send it to us, not to me, send it to the assistant, to Miss Kinde. Okay? So we want to have a proof that you are aware of these regulations. Okay? We have office hours, Zoom office hours. So those are mine. And this to the right, that's my Zoom number. Isaac, Engineer Isaac for you is here. That's the Zoom. And Miss Giovanna Kinde, she's going to be the assistant for this class. That's her Zoom hours, okay? All assistants are asked to come to the university. So if you have problem and you feel that through this online thing, you are not able to communicate. You may come to the university. Probably next week, I publish the hours when our assistants are coming to the university. So if you feel that the explanation that you receive, for example, about homework, is not quite clear, you may come during office hours. He or she will be there and she will ask, in this case, Ms. Kindi will listen to your explanation and go on, okay? So yeah, but so far this is online, okay? Hopefully next week we will publish our hours in person that they will be available to you. Is there any question, people? Any question so far? No?